Another one of the ideas of the normal distribution is this idea of the empirical rule. And the empirical rule is just a rule of thumb. All right, so it's an approximation, but and it gives us a rough estimate as to what to expect within the data. All right, but so this is just basically just a guesstimate. All right, so it's not always true, but it's a pretty good ballpark figure as to what to expect for normal data. And so what we say is that approximately 68% of the data lies within one standard deviation of the mean. So right here would be 68%. And then 95% of the data would be between two standard deviations of the mean. And then finally, from here to here, that would be 99.7% of the data. All right, and remember what we said, anything past 3 standard deviations is an outlier. So anything beyond that, and that makes sense because there's only 0.3% that's going to be on either, that's on both sides. And so the likelihood that that could occur is going to be very small. All right. Now, not everything, though, is going to be within 1 standard deviation, 2 standard deviations, 3 standard deviations. Sometimes it's a half or a quarter or even a fifth of a deviation. All right. So how do we approximate those probabilities? All right. Because that's what really we're figuring out. Like, for instance, what's the probability that something is within 1 standard deviation or 2 standard deviations or 3 standard deviations of the mean? All right. And that can lead to a lot of different sorts of things that for forecasting and predicting, trying to model the probabilities of data. All right, so one thing that we can use is this idea of standardizing data. And standardizing data can be done by using a z-score. All right, so a z-score, and this is an important definition, okay, so there hasn't been an examination that I haven't given that doesn't have the definition of z-score on it, but a z-score is the number of standard deviations an observation lies away from the mean. And what we can do is we can find a z-score, and once we compute it, we can translate it into the area under the curve, which is really the same thing as probability. And we're going to get there, all right? It's not all that difficult to do this, all right? So one of the first things that we have to do is we have to be able to read a z-table. And remember at the beginning, I was talking about the idea that for us to really compute the probability by hand, we need a couple semesters of integral calculus, and then we also have to be able to have some numerical approximations. You might have shut down after that, all right? But the z-table does all that heavy lifting for us, all right? So we're going to first of all get a z-score, and then we're going to use the z-table to convert that z-score into an area, and the area is just the same thing as a probability. One thing of note, you always want to round the z-score to 2 decimal places. All right. Now, the first thing I'm going to do is I'm going to show you all how to read a z-chart. All right. So now this table is one that you're going to be able to get from the Blackboard page. All right. So one of the first things you want to make sure of before you start this, go any further in this video, is to get this table. All right. So go ahead and download that, make sure you have it, and then come back to the video. Now, once you have it, what you want to do is you want to identify the positive and the negative sides. So the first page is going to be the negative side. So if you want, just write a negative at the top here. So I'm just going to draw a negative right here. All right. And then you can scroll down and there's a positive page. All right. So we want to make sure that we understand what this really represents for us. All right, so now in here are all the probabilities, and on the outside is the z-score. All right, so what you do is you use the column to be able to figure out or to locate the ones and the tenths place. All right, so you go to the rows, so you just keep looking down here for the ones and the tenths place, and then the hundredths place is always going to be the column, right? So our hundredths place is going to be our column. So you just kind of line it up like crosshairs. So first you go for the correct row by looking down here. Well, first you go to the right side. So you go positive or negative side. And then once you have the positive or negative side, then what you do is you just look up the correct row, and then finally you look up the column that's necessary. All right, so let's take a look and see how we can use the z-table and convert into our different types of areas. All right, so the first one that we have here is this z equals 1.59. So z is 1.59. Now, to figure that out, we're going to go to the table. We're going to go to the positive side first. Then you're going to go down to 1.5. So we're going to go right here, and we're going to find 1.5. And then finally, what we're going to do is we're going to go all the way over to 9. And what we're going to do is we're just going to kind of line it up like crosshairs. And we're going to go over, and right here is the probability, 0.94408. So the likelihood that we're going to be 1.59 standard deviations above the mean means that 94.408% of the data is below that value. All right, so just making sure you understand what that means. And I forgot the number already, but it was 0.94408, I believe. I'm going to go back and check it just to make sure. So 94408. Same thing we can do with z is negative. All right, so let's say for letter B, we have our z-score is negative 2.78. So what we're going to do is we're going to go to the z-table again. This time we're going to go to the negative side. We're going to go to negative 2.7, which is right here. And then we're going to go all the way over to 8. All right, so again, you look at, when you're doing this, first of all, you look at the first two decimal places, then you look at the ones place and the tenths place, and then you look at the last place. So that negative 2.78, so that's going to be all the way over. So we just go down to here, and we go all the way over to here, and that's going to be our lineup. So 0.00272. That's going to be 0.00272. Great. For letter C, we have z equals 0.07. Right, so we're going to go back to our table. We're going to go to the positive side first. So the table, positive side, we go to 0.0, which is right here. And then we go all the way over to 7, which is right here. And we get this 0.52790. So it's going to be 0.52790. Right? So this is actually pretty easy, right? Very little computation, we just have to line it up. Now for letter D, this one's a little bit tricky. Right? So we have z is negative 5.79. So we're going to go into our table once again, and we're going to run into a bit of a problem. So we're looking for negative 5.79. Yep. So we're looking for 5.79. And where is it? I don't see it anywhere. All right. One of the things that we're going to say, all right, is that anytime we have a probability less than 3.99 negative, we're just going to say that the probability is approximately 0. All right. So what we can say is that, let me erase this so we can write down. And if you want to write this on your table, you're certainly welcome to. In fact, it might be a good thing for you to note. Okay, so trying to erase this so we can just write it on the table really quickly. So we're going to say that if z is less than negative 3.99, okay, that means that the probability is approximately 0. Right? And that kind of makes sense because right here it's 0.00003. All right, so that's about 0 anyway. Just as a note, if we go down here, notice that there's nothing bigger than 3.99. All right, so in the same vein, if z is greater than 3.99, the probability is approximately 1. All right, so 0 if it's not on the chart on the negative side, 1 if it is on the chart on the if it's not on the chart on the positive side. All right, so hopefully that's not too difficult for you all to be able to compute. All right, so let's take a look at a couple additional problems in being able to compute with respect to these z-scores and the normal distribution. All right, so let's say for some reason we have a mean of 155 and we have a standard deviation of 17. And let's assume that the data is normally distributed. Let's compute the following. So the first one that we have is we have the z-score, the probability that x is less than 145. All right, so let's first of all draw a chart. So for letter A, here's our chart. All right, I know it's not a good normal distribution, it's good enough. In the middle, we have 155, because remember in the middle, we always have the mean. So your mean is right here. And 145 is only 10 away, and the standard deviation is 17, so it's less than 1 standard deviation. So let's plot 145 right about here. Okay, so just think of it like a number line. 145 is less than 155. And the probability that x is less than 145 is going to be all the area to the left, because it's a less than problem. All right, so how do we figure out that probability? Well, we use our formula z equals x minus mu divided by sigma. Okay, so that was this formula all the way back right here. And in this example, x is 145, mu is 155, and then we're going to divide that by the standard deviation, which in this case is 17. So let's plug that into our calculator. So we're going to say parenthesis 145 minus 155, and we're going to divide that by 17. I accidentally put 2 parentheses in here, so since I didn't want a syntax error, I just put 2 parentheses at the end. You really only need 1. All right, I'm going to hit enter. Negative 0.580, and we round z-scores to 2 decimal places. So our z-score is going to be negative 0.59. All right. Now that is not the probability. The last thing we have to do is we have to go to the table. So we're going to go to the z table, and we're going to look up negative 0.59. So we go down to negative 0.5, and then we go all the way over to 9. Right? So this is 9 up here. This is negative 0.5, and we crosshair it, and we get 2776 as our probability. So that's going to be 0.27760, or 27.76%. Okay, it doesn't really matter which one it looks like. All right, now to make sure that makes sense, we look over here. And we look at this, and if we were to estimate this, it would definitely be less than 50%, because remember, the line right here is the 50% mark. So our probability should be less than 50%, but it shouldn't be like 1% or 2% or 5% just by looking at the drawing. All right, so the drawing can help you to approximate what your solution is. All right, now for letter B, this time what we're going to do is we're going to say what's the probability that a randomly selected element is going to be greater than 180. Right, so we're going to draw this. So here's a much better distribution than last time. 155 is still in the middle. Now 180 and 155 are about 25 apart, so it's more than a standard deviation. So let's plot it maybe right about here to the right, since 180 is bigger than 155. And since x is greater than 180, we're going to shade this area. All right, so you look at the inequality symbol. That's going to tell you whether to shade to the right or shade to the left. We're going to use our z formula. Z is x minus mu over sigma. And in this case, z is going to be equal to 180 minus 155 divided by 17. We're going to round that off to 2 decimal places. All right, in our calculator, 180 minus 155 divided by 17. And that leaves us with 1.47. So that was an easy one. 1.47. Now remember, that's not the probability. All right, what we have to do is we have to go into the table and we have to look that up. All right, we're going to need to convert that. All right, so we're going to go to the z table and we're going to go to positive 1.4 in our table. Let me erase some of this stuff that I've already done. And so we go to 1.4 and then we go all the way over to 7. And 1.47 is this 0.92922. So let's go over here, and that's 0.92922. And that's really going to be what? 92.922% of the data. Now, the question is, does that make sense? And clearly it doesn't. Okay, so that doesn't make sense because this probability should be much less than 50%. What is 9.222? All right, well, or 92.222. Well, 92.222 is the area below that 180. All right, so this is the 92.222%, or 92%, excuse me. All right. So how do we figure out the rest of that? Well, what we're going to do is we're going to take the complement. All right, so for a greater than problem, since the total area under the curve is 100%, we're going to do 1 minus 0.92922 in our calculator, and that's going to give us the other area. All right, so that should be 0.07078. All right, but I'm going to check that really quickly in the calculator. So we're going to say 1 minus 0.92922, and we get 0.07078. I didn't trust myself, but I should have this time. All right. So for a greater than problem, what you're going to do is you're going to go ahead and subtract, right, from 1. All right, one last example. And this time what we're going to do is we are going to find a between area. So this one says, what is the probability for letter C that some randomly selected observation is between 151 and 162? So on our data distribution, here's our normal distribution. In the middle is still 155. And we're looking for the probability that X is less than 1 or is greater than 151. So 151 might be right about here, and 162, which might be right about here. All right, so they're pretty close, and this is the probability. All right, so now this is a problem because we have our formula, x minus mu over sigma, and we have two x's. We have 151 and we have 162. All right, so the question is, how do we figure out the probability? Well, what we're going to do is we're going to find two areas. Right? So we're going to find the area for both of the z-scores, and then the area that's in between, which is this area right here, it can be found by subtracting the areas. Okay, so for a between problem, what you're going to do is you're going to find two z-scores, you're going to find two areas, and then you're going to subtract the areas. Okay. Note, do not subtract z-scores. Okay, only the areas. Okay, so that's important. Otherwise, you won't get the right answer. So let's get to it. I'm going to call one of the z's z1, and I'm going to call the other z z2. And what I usually do is, in fact, what I personally always do is I always make the bigger value correspond to z1. Okay, so z1 is the one with the bigger x. All right, so I'm going to use 162 minus 155 over 17. And for z2, I'm going to have that be 151 minus 155 over 17. All right, so now let's go in our calculator. we're going to do parentheses 162 minus 155, and then we're going to divide that by 17. And that's going to yield 0.41, so just 0.41. That's going to be approximately 0.41. And then over here, we're going to do 151 minus 155. So we're going to do parentheses 151 minus 155. And then we're going to divide that by 17. And that's going to yield negative 0.24 approximately. And remember, we're always rounding z-scores to 2 decimal places. And you might be wondering, well, why 2 decimal places? All semester, we've been doing 3 decimal places. All right? Well, the reason is because we go into the z-table, and the z-table only has 2 decimal places. Right? So now let's go to the z-table. We're going to look up 0.41. So in our z-table, we have 0.41, 6591. Now technically 65910, but we can just say 0.6591. And then let's go to negative 0.24. So negative 0.24 is going to be, I think it's going to be this number right here. Yep. So it's going to be 40517. So we go to our chart and we have our 41507. Just double checking. 40517. Yep, good. Last thing we do is we subtract these numbers. So 6591 minus 0.41507. And before I hit enter, I'm going to check it just one more time. So 6591. Yep. And 41507. We hit enter, and we get 24403. So that's going to be 0.24403 is our probability, okay? Or 24.403% for our probability. All right, so a lot of stuff to digest in this video, but these are the rudiments of what we're going to be using throughout the remainder of the semester when we're computing z-scores. So the next video, we're going to take a look at an applied problem, and in the final video, what we're going to do is we're going to look and go backwards to be able to find the value of x given the probability.